Prepare to be amazed by NASA's bold new venture. In an exciting leap forward for atmospheric science, NASA has just unveiled the Carruthers Geocorona Observatory, a mission that promises to deepen our comprehension of Earth's atmosphere. This ambitious project is designed to scrutinize the planet's geocorona, an ethereal halo that stretches from about 300 miles above the surface and reaches nearly halfway to the moon. By employing state-of-the-art ultraviolet UV imaging technology, NASA intends to capture in-depth images of this phenomenon, which is invisible to the naked eye. One of the primary goals of this mission is to analyze hydrogen loss, a critical aspect for understanding the potential habitability of exoplanets. This initiative not only carries forward the vision of Dr. George Carruthers, but also represents a significant milestone in our quest for cosmic knowledge. The observatory's journey to Lagrange point L1. The Carruthers Geocorona Observatory embarked on its journey from the Kennedy Space Center in Florida at 7:30 a.m. EDT, launching alongside the Interstellar Mapping and Acceleration Probe, IMAP, and NOAA's Space Weather Follow-on, Lagrange 1, SWFO L1 satellites. Together, these missions are heading toward the L1 Lagrange point, a strategic gravitational sweet spot located between the Earth and the Sun. This position allows the observatory to maintain stability while collecting data without the distortion caused by Earth's atmosphere. Thus, positioning the observatory at this unique point is paramount for obtaining precise and detailed information. Once it arrives at L1, the observatory will enter a commissioning phase, with plans to begin data collection by March of next year. The anticipated mission will span 2 years. However, if its objectives are met with success, the operational timeline could be extended, enabling a more comprehensive data-gathering experience. Delving into the mysteries of the Geocorona. The Geocorona is a strikingly luminous feature that encircles our planet, yet it remains largely mysterious. This phenomenon was first formally observed in 1972. When astronauts aboard the Apollo mission used a rudimentary UV camera on the moon. Although the images captured were breathtaking, they fell short of revealing the full extent of the exosphere, largely due to the technological limitations of that time. The visionary behind that early camera was Dr. George Carruthers, who has long dreamt of a mission capable of capturing the complete picture of the Geocorona. The recent launch of the Carruthers Geocorona Observatory represents the realization of his aspirations. Featuring advanced UV imaging technology, this observatory will allow scientists to obtain detailed images of the exosphere and examine its interactions with solar particles and the lower atmosphere. By offering a comprehensive view of the Geocorona, this imaging technology will illuminate the processes happening within the exosphere, specifically how Earth loses hydrogen, an essential component of water, to the vastness of space. Understanding how hydrogen is lost is vital for scientists in their search for exoplanets that may harbor life, as it offers insight into the ability of other celestial bodies to retain water. Advanced imaging technology. A remarkable advancement. The imaging capabilities of the Carruthers Geocorona Observatory signify a considerable upgrade from the apparatus used during the Apollo missions. It features both wide-field and near-field imaging systems. The wide-field imager provides extensive, sweeping views of the entire exosphere, while the near-field imager hones in on interactions at a more granular level. This dual approach not only enables thorough analysis of the Geocorona, but also generates insights into its composition and dynamics. The improvements in imaging technology serve as a testament to the advancements in UV imaging over the past 5 decades, heralding the arrival of unprecedented clarity and precision that scientists will use to decode the complexities of the Geocorona. These new imaging capabilities are not merely technical advancements. They are critical tools necessary for unlocking a fuller understanding of planetary atmospheres. This knowledge is indispensable for identifying exoplanets that possess conditions conducive to sustaining life. The Carruthers Geocorona Observatory is at the cutting edge of this exploratory venture. The impact on the quest for habitable exoplanets. One of the most compelling facets of the Carruthers Geocorona Observatory's initiative is its potentially transformative insights into the search for habitable exoplanets. By investigating the dynamics of the geocorona and the loss of hydrogen, researchers aspire to enhance their understanding of how other planets might manage water retention. Water is fundamental for life as we know it, and its relationship with hydrogen is utmost essential. By understanding the mechanisms behind Earth's hydrogen loss, scientists hope to refine models regarding exoplanetary atmospheres, paving the way for a more focused search for planets inclined to support life. The findings from this mission could fundamentally shift our comprehension of what constitutes a habitable world. While data is collected, scientists may discover new markers of habitability, thereby enriching the prospect of finding extraterrestrial life beyond our solar system. The Carruthers Geocorona Observatory embarks on a mission that bridges past ambitions with the exciting potential of future discoveries. As it sets out on its 2-year scientific journey, the observatory encapsulates the dreams of scientists keen to decode the mysteries of Earth's atmosphere and the limits of our universe. As we gaze toward the cosmos, one question looms large. How will these new insights influence our quest for life beyond our planet?